Hello, everyone, and welcome to Episode 8 of Nelson's Corner with your host, Mr. Nelson LeKay. Welcome, Nelson.
Hey.
And also joining us, we've got Mr. Zach Parrish.
Good evening, folks.
And myself, Jason Busby. We are continuing tonight with the third part in the series of Introduction to Design Patterns. Nelson, take it away.
All right. Well, I guess so. The first pattern that we are going to go over, actually, to kind of recap our the last episode. Do you have any notes about that, Zach? Have you done any more thinking?
Well, I have all of the notes that we took last time. We discussed the MVC pattern, Model View Controller pattern, which allows for, well, it's a means of writing your code such that you have a model class which represents all of the logic in your application. Basically, it's the part of your code that does stuff, performs operations. You have your controller class. This is the class that will take everything the user is doing and convert it into an action, telling the model what to do. It will also interact with the view. And then you have your view class, which is more or less responsible for just presenting stuff to the user.
All right, sweet. Yeah, that's a pretty good overview. And like I said in the last video, generally most of your classes are going to be one of those three in a loose sense.
Right, so it's not that
it's not concrete.
A model class, a controller class, and a view class.
They kind of fit under those headings, I suppose you could say.
Right. And then underneath that umbrella, you can often actually apply, well, you often do apply other patterns in addition. So I just want to say right now, if you're using the MVC pattern, there's no reason why you can't use like the Singleton pattern, which we're going to go over next.
Well, what all are you looking at discussing here?
Well, we're looking at the Singleton pattern, the factory pattern, and the repository pattern.
Okay.
And that is of course, time permitting on the repository.
Yeah, definitely.
Okay, all right.
Depends on how long we talk about factoring and Singleton.
Yeah.
All right.
So Singleton pattern is pretty straightforward. Essentially, if you've ever worked in a language with globals, you'll understand kind of what the Singleton pattern is doing. Zach, have you ever worked in a language with global variables?
Sure. Well, I mean, a scripting language, Mel has global variables if they're the same thing. Basically, a variable that is visible outside the scope of whatever it is you're looking at it at the current moment.
Right. Well, the Singleton pattern is an object-oriented way to express what would be a global variable in another language. And with that comes obviously the baggage of global variables and how they could, in some cases lead to problems. But at the same time, singletons are something that you're going to have to know about and will be something that you can use, to good effect. So the basic singleton pattern is a class that you create that only has one instance to it.
Okay.
So it's a class that's only instantiated once. It's kind of important to know that you can accomplish the same thing with static classes, with static members, but generally the singleton pattern allows you to pass around a reference to that object, and I'll show you what that means in a sec here. Let's say we have a static class. Okay, so static classes, Zach. Static classes and static members?
Bad timing.
Actually, thinking about it, when we did a review over classes, I don't know if we talked about static classes.
Yeah, I don't think we did at all. So, to basically introduce anyone who doesn't know, and Zach, to static classes and static members, a static class, well, it's more important to define static members first. A static member is any member, so a member being a method or a field or a property or an event, that is defined with the static modifier. So you got the static modifier in here, and this defines this this method as static, or this member as static, because you can do the same thing with a field, for example. So what a static member does is, a static member is a member that you can call upon that isn't actually associated with a instance. It's something that you can invoke without a reference to an instance, and an instance being a object that you instantiate with the new keyword. So do you see how we can call things on doer of stuff without actually instantiating a doer of stuff? And if we were to instantiate one...
I see that you are doing it. The why is really just based on your definition, saying that because we invoke this as static, I guess we don't have to.
Right, and if we do stuff dot, we don't see things here.
Mm-hmm.
So this member isn't accessible via an object. It's only accessible via the class name dot and then the member. And to kind of all right, well, let's do the basic hello world example of static stuff. It's important to know that static members are shared between all instances of an object. So you'll see that when we have this var stuff equals new doer of stuff, and then we do a console.writeLine on doer of stuff.stuff count, we will get 1. And the reason we get 1 is because we instantiate the doer of stuff, which invokes its constructor, which references the static member and increments it. And then we echo that out on this next line. So if we were to instantiate 2 doer of stuffs, we demonstrate that the stuff count is actually shared. Because you see we instantiate 2 of these things, a constructor gets called twice, but this reference to stuff count is shared between the 2 because there's only 1 reference per class.
Right.
Because it's static. So do you kind of get what's going on there?
I see what's going on there. The static thing is still very new to me, but we can go ahead and move forward anyway, and I'll just do my damnedest to keep up.
Well, if you had something like you wanted to put together a class that had some helper functions in it, or for example, like let's say, console.writeLine.
Oh yeah.
Hey, I was looking for an example, and you had the little tooltip up. It's like, well, that's perfect. Do you see Nelson having to instantiate an instance of console in order to then call upon his new instance of the object or instance of the class to call WriteLine? Instead, he just says console, so that's the class dot WriteLine, because the class itself is static.
Right. And, well, in this case, it doesn't have to be static. I actually do believe that console is a static class. Yeah, it's a static class. But what makes a static class is a class with a static modifier on the class itself.
Correct.
And what this means is that no members
can be instanced members.
No instances can be instance members, and you see that right here. Doer of stuff cannot have non-static constructor because it's not a static object, and it is a static object and class, and also can't be instantiated because, well, it's a static class.
True, but I'm just trying to keep it real simple at the moment without getting further into rules, just so that Zach sees, oh, I see why that would be relevant. Where in this case, we use console WriteLine in these examples all the time, and read line or read key. And it would really start to feel just kind of clunky if we had to actually instantiate that class so we could call upon that functionality. Another example would be, you've seen Lee and I work with a game manager in some of our Unity games before. So we're working in a game, and how many game managers do we need in a game? Just one manager. That's an example of a place where it could be a static class. Then everybody could reference it by just saying game manager dot. It would be
instead of having to instantiate a new one.
Instantiate it, and then pass it around, because if you instantiated multiple game managers for one game, now that would be just really odd to do something like that.
Okay.
So just trying to give you examples to help picture why you'd want to do something like this.
Okay. So so do you kind of still are you still kind of fuzzy about static or?
No, I see what it's doing in a sense that it is kind of, isn't that kind of functioning like the global variable, or like the idea?
Yeah,
Yes.
it's
Yes.
Yeah.
Okay. Yeah, then I'm good.
The singleton pattern is a way to essentially wrap all this static stuff in an object-oriented way. So you see that we have okay, so let's make this a static class. And like I said, static class can only have static members. And let's give it some functionality. And obviously the functionality is unimportant, but you would represent any static functionality as, like what Jason said, functionality that should only be ever tied, should only ever be used once in the context of a single object.
Sure.
So you see that we now can do, say, doer of stuff dot increment stuff count, doer of stuff dot print stuff count, doer increment, doer print. And you see we have this. So
It's just an easier way to call on that functionality without having to, well, in a sense where you know you're not going to want to be able to instantiate another one, or where you're not going to need to.
yes, but the problem is there's lots of problems with this.
Uh-huh.
That was kind of a weird statement, but
The problem is that there are lots of problems with this. No, I like it. Let's roll with it. So what are some of the problems with this, other than the fact that there are problems with this?
well, first of all, you cannot pass around instances of doer of stuff. And what I mean by that is if we have a static we cannot do this because doer of stuff is static, and this doesn't, well, make any sense because this can't be instantiated.
Okay, yeah.
And that's an issue because now all your code that relies on doer of stuff, just like all of your code that relies on console, requires that you reference this class every single time. You have to reference doer of stuff dot
something
everywhere in your code.
Right.
There's nowhere to hide that because you can't alias it out into a variable or a method argument.
Okay.
The next problem with it is if we wanted to use interfaces. For whatever particular reason, and we want this interface. In this case, so now we can alias this out into an argument because we can. It's an interface, so interfaces can be variables or arguments.
Right.
But the problem is there's no way for this static class to actually implement this interface. So if we ever want to satisfy this argument with a reference to the doer of stuff class, we can't because it's a static class and can't be instantiated and can't be casted into an interface.
Okay.
So that comes into a huge problem as far as design goes, because now not only are you referencing this code, this doer of stuff class, everywhere in your code, you're also not able to have it implement any interfaces, which reduce the amount of functionality that, or reduces the flexibility of the class. And I have in so many instances where static classes will destroy code bases. A person will have a static class, and that static class might make a specific call to a to maybe the HTTP context, which is an ASP.NET static class that does stuff, or it might do something that's platform specific. You want to take that code and make it no longer specific to that platform. You want to execute your web code in a console app, and now you have to go through and you have to change all your references to the static class. There's no way to cleanly re-implement this interface with your different platform code that doesn't rely on the web and pass it around in your code, because you have to replace all of the instances of the static class with something else.
Right.
So static classes are really lead to a lot of design problems. So to fix that,
does that mean you shouldn't ever use them?
Oh no, there's definitely instances
I mean,
where you should.
well, it's like you started off by saying, here's why they're useful, and then you've kind of gone off on this really long tangent of how they destroy code bases and how they lead to all these problems. And the language that you're choosing to use right now really makes it sound like you should never touch these things.
Yet Jason turned right around and said, "Here, let me make it simple. Console.WriteLine. Oh, isn't that done by Microsoft?"
Yeah. So I mean, is it one of those time and place things, or do you recommend we never use these, or what?
I recommend that static classes should be avoided if you can cleanly make it implemented in a different way.
Okay.
If you can cleanly abstract this into an interface or cleanly pass it around in method arguments or do whatever, that will make your code more flexible because your code no longer relies on the static class. But obviously there are instances where static classes are not just necessary, but preferred. And an example of that would be the GUID class. Do you know what a GUID is?
I've seen the term before. I mean, I keep thinking user interface, but I have no idea really.
A GUID stands for a globally unique identifier.
Okay.
And GUIDs are really cool because when you generate them, they're guaranteed to be unique in the entire context of your application. And you can actually see what a GUID looks like by going to Tools, Create GUID. And you see all these cool little symbols you might have seen in your registry or something, and there's different ways you can do it, and you can regenerate them. And GUIDs are really useful in cases where you need to be able to generate unique IDs, maybe in a multi-threaded application, without conflicting with anything else.
Yeah.
So that's a quick overview of GUIDs. Now here's an example of a static method being used to great effect. We could instantiate a new GUID, like this. But it's going to be, with this, it's going to be 00, it's going to be a blank GUID.
Okay.
Or we could pass in, strings or bytes or ints or whatever to turn it into another GUID. But there's no way to generate a GUID with this interface. There's no constructor that lets you generate a new GUID.
All right.
So in order to make GUIDs more useful, in order to allow you to generate them in your code, Microsoft introduced the GUID.newGUID static member, which returns an instance of a new GUID.
Okay.
So that's an example of static members being used in a situation where they're appropriate. Now, the reason why it's appropriate is because this new GUID is a simple type. That's the first indication here. A GUID is also something that's never really going to change because, well, a GUID is always a GUID.
Well, I don't mean to beat you up or put you on the spot or anything, but it's all well and good to say that here's some integrated command or something that I can pull right out of Visual Studio that's already static, and it's a really good example of it, and that's all great. But, I mean, in terms of actually coding something and creating something on your own, what's a good example of something that should be static? Can you throw something out there?
Well, what about? I mean, there are a few examples actually I can pull out that are that I use static members, but it would take more time to explain why I had to do it than it would otherwise. Jason, do you have any quick? I mean, like the game manager in Udity is an example of something that, but. To be honest, I don't know anything about the game manager.
That's okay, and I followed Jason's example. I was just seeing if you could come up with a quick code example, just so you weren't relying entirely on things that were kind of already built in.
They're good for instances of creating objects, like creating the object that they're surrounding. Like you saw with the GUID. So if we were to create. But see, that usually goes in. It is kind of an edge case, to be honest with you. Okay. I don't find myself using static members very often, but when I do, they're necessary and they're not something to be afraid of. But it's really difficult for me to come up with a non-convoluted example.
That's
so. Let me play the role of Zach real quick and ask him one other question that he might not have thought of yet, and that is: so Nelson, if I get on Google and start searching for some additional information about the relationship or the decision to go with the static class versus the Singleton that we're coming up on, am I going to find any programmer wars out there?
You might. Might. As always, the design crowd really does have its own internal wars. But like I said, though, I actually have good reasons why to avoid static classes in lieu of using an interface, or not an interface, but a singleton.
I think with you saying that, Zach was just looking for your concrete static examples. You gave an example about the passing. So you gave the example that favors the use of singletons, which we've yet to really talk about. But I think he was looking for, well, what would be the good reason to use a static then?
It's hard because I generally, in my own code, try to avoid them.
Yeah, because
when they do, or when they are appropriate, it's clear to me. But it's hard to distill that clarity, I guess you could say.
Yeah.
Like I said with the GUID example, the static member provided a way to create an object that wasn't appropriate to put in a constructor.
And see, that's what I'm trying to pull out of you. It's like, okay, so I'm totally new to this whole thing, and I'm going to be coding, and I may sit down and have a moment where I think that a static might be appropriate. But you're telling me that you've got this kind of secret magical intuition system that tells you to avoid them, and that when you use them, it's because this secret magical intuition system has told you that it's okay to use it. I don't have this secret magical intuition system, so I'm hoping you can help me.
I'm trying to think of hold on. Let me think real fast of an instance where I had to use a static member that isn't convoluted. I mean,
for me personally, if like when we're working on game stuff and there's going to be some type of helper class that is actually utilized by everything throughout the program, but it doesn't have the type of the functionality is very encapsulated. Like an example would be like if you were to put together some type of math class.
I was actually about to say something to handle math equations for you.
If you're going to ask for the square root of something, or if you're going to ask for this, or I want the distance between 2 points, etc.
Right.
That's not going to ever need to change.
Like a triangulation system.
And so
give me the sign of this. And
so that could simply be a static class that then everyone could rely on getting the distance between 2 points in 3D space, or the square root of something, etc.
Okay.
Because you'll never need to
modify what that actually
modify.
Does. You're just going to utilize what's already in there.
Right. So you're not going to code yourself into a corner with something like that. It's just simply available to perform some standard operations that will never change.
But I do want to say that you should be very careful about deciding those kind of operations. Like Jason brought up a really good example. Math stuff, never going to change. But if you have business stuff, that's...
yeah, that's different.
Sure. And well, this also might be kind of a dumb question. I'm not really sure, but we've talked a lot about using ReSharper, right? Is it possible that ReSharper could assist you if you did already kind of put yourself into a corner with writing out a bunch of references to a static class that you now know you need to go back and change? Or do you even, I don't know if you've ever even tried to do that. It seems like something that could help you out.
Mentioning static is pretty funny, and this probably irritates Nelson. It's hard to say, but ReSharper is really good about saying, hey, this should just be static.
Yeah.
It does do that. And it's because that, it's actually the reason it is kind of archaic. It has to do with the size of the object in memory. But yeah, so not that I know of. I've never encountered a ReSharper command that'll automatically do that, because there's no way. If I were to do this, and I were to say, okay, doer of stuff should no longer be a static class, there's really not many ways that ReSharper can say, okay, here's an instance where you call this, turn it into a reference to an interface that somehow magically...
Sure.
It's just too complicated.
I understand. I've seen ReSharper do some pretty amazing things, so I thought I'd just kind of throw it out there and ask if you'd ever seen that.
Okay. Yeah, but no, I haven't, unfortunately.
Okay.
Okay, so we kind of described the problems with static classes.
Yeah.
And then, kind of, just to reiterate, the problems with static classes, we always have to reference them everywhere in our code. We have to reference them by name. The other problem is they can't implement interfaces. If I were to do this, I would get an error. They cannot be aliased into variables or method arguments. And those are the biggest, and they cannot be replaced at runtime. Meaning you can't replace the implementation of a doer of stuff during runtime, whereas if it was an instance class, you could just send in another doer of stuff. But in this case, there's only one instance, I guess you could say, even though it's not really an instance. Okay, so then to fix this, people introduced the Singleton pattern. And the Singleton pattern is kind of about having a class that should only ever be instantiated once. There's no real reason to use a Singleton class more than once, but you don't want to code yourself into a corner in the same way that you would do with a purely static class. So to refactor this static class into a Singleton, we have to remove the static modifier because it's no longer going to be a static class. We also have to turn all of our static members into instance members. At this point, we can now implement this interface. Kind of. Oh, I spelled that different. Increment. That's wrong. Yeah. Okay, so now we can implement this interface, and now this is a normal class. The problem with this class is it can't be instantiated. And you see all of a sudden all these break, so we have to remove all this. The problem with this class is that while it can be instantiated, it can be instantiated as many times as we want, and that's what we want to avoid. So we have and this is a problem because this obviously breaks our intention of this class only ever being instantiated once. So to fix this, the quick fix would be to give it a private constructor. And a private constructor is a constructor just like every other constructor, except for it's private. So it cannot be accessed outside of this class. So you can never new up this class anywhere else outside of this class. And so now you see that there's now an error. So we can just delete this code. But now we have a problem because there's no way to there's no way to get this class back. We've now made this class uninstantiatable. So we have to actually I actually should have brought this up on your last question, because we actually have to use a static member right here in this instance to facilitate our Singleton pattern.
Yeah, you just hadn't thought of it yet.
So in order to do the Singleton pattern, we have to have a static reference of doer of stuff. Weird naming conventions. Then we have to have a public static doer of stuff instance. So we have to mediate all of our code that ever gets a doer of stuff through this one class, through this one method. We have to funnel every request for this class through this one method. And the logic of the method is going to be pretty straightforward. It's going to be if Singleton is null, meaning it hasn't been instantiated yet, then instantiate it, and then just return it. And this can actually be broken into a ternary or a null coalescence, but I'll just leave it more clear right now. So now that we have this public static method that returns a doer of stuff, we can now call it to get the single instance that will ever be created of this class. And we do that by just doing get instance, and now just to make sure that it lets us use interfaces, we can do an iDoer of stuff. And then we can now pass our Singleton into this static method, so that now we can actually replace the implementation of this iDoer of stuff with anything that fulfills that contract. So now our code is more flexible, even though behind the scenes we're still using a single instance. So if we run this, we'll get
an error because there's a comma.
Yeah.
we'll get 1 because we incremented it once, then we printed it.
Right.
Okay, so do you kind of understand this pattern so far, Zach?
I understand what you're doing.
So basically, you mind if I?
Please.
Yeah, so basically, the bottom line is we've got the class doer of stuff.
Yeah.
We need to somehow solve the problem of we cannot allow there to be multiple instances of it
this
running
class. Right. There can only be one.
There can only be one.
Right.
But we don't want for the class itself to be static.
Mm-hmm.
Now, the way you instantiate is by...
Just help me out real quick.
Yeah.
I mean, and I realize I might be forcing you to repeat yourself, so bear with me. Why wouldn't we want this to be static?
Well, this gets back into a situation where we need more complex...
Mm-hmm. Okay.
A more complex piece of software for it
Right.
to really become clear.
Okay.
The biggest thing that Nelson's using to demonstrate or to back this up for him is being able to pass around the interface type, which is what he's actually doing down here.
Sure.
In this particular case, we then could have one particular class that's going to handle a series of calculations that's based off one interface. We could have another interface, but the bottom line is these two different classes that use two different interfaces completely.
Right.
We would know at any given time during application life there would only be one
only have one of
instance of each of these classes. And so if we have different methods, this method could take this, and if we need it later on to change it, all we do is just change the interface, and then we're going to take in a whole other guy, which could have different functionality implemented.
But still, you wouldn't have multiples of them running around.
But we would still know there's not multiple instances of that class in existence. I mean,
does this come down to a memory management thing? Like
No.
No. Okay.
It comes down when you're in a design, when you're working in design, and you have a class that should never be instantiated more than once, because it wouldn't make sense to.
Yeah.
Instances of that are like the game manager, where it wouldn't make sense to have more than one game manager.
Right. Okay.
It wouldn't make sense to have more than one program object like this, because that doesn't make any sense.
Or even going back to that earlier example of a math helper class, you don't need multiples of that, obviously.
Right.
You just need to use what's in there.
Yeah.
Okay,
So,
I mean, I see what you're doing in that regard.
But see, here's the kind of the beautiful thing about the Singleton pattern, is that it allows us to write code that has no idea that this is a singleton. This doesn't care that's a singleton.
Right.
Maybe your business requirements change and you need multiple doer of stuff instances. Well, in that case, the only code that you have to change is whatever calls to get instance, which should be at the very top or in another. It should be in, if you're using IOC, which we'll definitely get into. It should be somewhere else. I mean, what I'm saying is you can treat this object just like an object. You don't care that it's instantiated more than once. It's just we're enforcing that it's this particular implementation of this interface will only be ever instantiated once, because we're routing all calls to its one instance through this single method. And this single method, according to the logic, says that if the singleton is not null, just return the singleton, otherwise instantiate it.
Okay, yeah. Basically, we need something there, so if there's nothing there, give it to us. If there's something there, return it.
Yep.
Yep. I'm with you. Now, okay, here's just another... It's a point, it's kind of an observation, maybe also partially a question. It's just something I've kind of noticed about this. It seems like this is like a design pattern that you would probably implement along with maybe some other design patterns as well. I mean, it seems like this is just something that you'd notice, like a particular kind of class, and so that that needs to just have one instance of itself, and so you turn that into a singleton, even though you might have already been using like MVC at the time. Or am I totally off? Am I off the reservation now? I mean,
Well, design patterns are mix and match.
That's kind of what I'm getting at. That's what I'm noticing. And honestly, when we first started getting into the discussion of design patterns, that hadn't really occurred to me. I wasn't sure if you pick one that works well for your project, or do you take multiples and start mixing them together, or what?
No, you don't at all. I mean, the singleton pattern goes hand in hand with a lot of stuff. I mean, you'll see instances where your model code has a singleton pattern in it, or maybe your view code has a singleton pattern in it. You know what I mean? It's like, it's definitely mix and match depending on what you need to do.
Cool.
So, Jason, how do you feel that the explanation of singleton patterns has gone. I mean,
Well, you could just...
is there anything I've missed?
Well, no, not really, unless we wanted to start discussing multi-threaded applications that are utilizing singleton, because there are some special things to take into account. But I understand what you're doing, but I'd advise just skipping it at the moment until we get into a threaded discussion,
Sure.
or discussion on threading, and then we can come back to that since we've talked about singletons.
Okay, and this might be a cool time to introduce null coalescence just real fast because I like it. You see ReSharper already told me about it. Null coalescence operator is right here. Null coalescence operator means if the left-hand operand is null, return the right-hand operand.
Right.
If the left-hand operand is not null, return the left-hand operand.
Yeah, it's very cool. It's very nice.
I can see you liking that because it takes a bunch of code and puts it into one fairly cryptic-looking single line.
No, once you understand what it's doing, it's no longer cryptic
I know.
looking. I like the line myself as well.
And this could be broken out into a ternary, but yeah, whatever. That would be more verbose.
You can't have
so
that.
And, Nelson, to be honest with you, what I'm going to do is I'm going to keep tonight's video, since we've had two really long ones. I'm going to keep tonight's short because we're coming in on 40 minutes.
What?
Yeah, we're already coming in on 40 minutes on what you thought was going to be about 6-minute discussion.
Yeah, actually, right before the video, Nelson had said that singleton really took no explanation at all, which is true. We actually spent a pretty good time getting up to speed on static classes and static members, which was good.
And while it's real easy being able to visualize factory methods and abstract factory patterns as being another 10 minutes, we can easily
turn into another
open ourselves up into another hour on that with the discussion and everything else. But for a recap, instead of you hitting your notes, explain it. Because that'll answer Nelson's question of, do you think it was explained well enough? Well, the bottom line is, did Zach pick up on exactly what's happening and why it's happening? Because that's the key with the singleton. Just understand why it's happening.
Well, what I was able to pull out of this was that the singleton pattern is here to solve the problem of having a class that you know without a doubt is not going to need to be instantiated more than once in your code. And we've cited a few examples. Understand, with my position, it's a little interesting for me to try to come up with one off the top of my head that falls outside the realm of our examples. So,
but a particular class that you'd only need one, like a helper class.
A helper class is a good one. I mean, my brain just hugged right onto that one because, like, if I'm writing an application that's going to have to do a lot of trigonometric functions, then if I have a single class that can solve for sine, cosine, and tangent, I don't need to be instantiating that over and over again throughout my code. So if I use a singleton pattern, there you go, and it's probably already there, but still, man.
Yeah, it's the example.
I'm just throwing out a random example. Then it seems like a nice place to use a singleton because you're not going to want to make multiple instances of that. You're just going to want to have it there once so that you can call on its functionality from anywhere.
Okay, and then to create a singleton?
Now that I would have to look back at my notes
So
on.
let's scroll back up.
Yeah.
Just so you're looking at it. We don't even have to worry about the interface stuff.
Well, it started off with the private static member, which now in his particular case, it's God. I have such a fun time reading exactly what that's doing.
That's why earlier, but you cut me off right in the middle of it. I was just starting on a flow to walk through what was happening and give a kind of clearer picture because Nelson.
I'm
was
sorry, I didn't mean
there.
to cut you off.
That's okay, but you jumped me off with questions, which you and Nelson then jumped into another discussion, and I figured that rather you had it or we'd come back to it, and I'd make sure you had it. So the key to everything in creating a singleton is what type are we defining with this class? We're defining the type, the doer of stuff, right? Because this is our template for what doer of stuff is. And it's not a static class, so we can instantiate this. So we can make instances of this class as objects. So we're holding a type here, a static type. The type that we're going to hold a reference to is a doer of stuff. So basically, we're going to hold a reference to an instantiated object that has been instanced from doer of stuff. So we're going to hold a reference of an instance version of this class from an object that was
within the class itself.
Yep, within the class itself, we're going to hold an instance to it. Okay, so this static guy, he's shared by everybody else in here.
Right.
Anybody can get a hold of him from the inside.
Right, because he's private.
He's private.
Right.
That's right.
He's not outwardly accessible.
So we've got that. So we've got a place to store a instanced version of ourselves, but we still have a problem.
Singleton.
We still have a problem. Yeah, under the name
Now,
Singleton.
is that a standard, or is that just you generally would name it anything, or do you find yourself utilizing a name like that just to help yourself out?
I would put. This goes back to the usefulness of the design patterns in communicating intent.
Right.
By calling it Singleton, every developer who looks at this code understands exactly what the intent of this system is.
That's kind of what I was getting at. It's like, as a programmer, do you see like the nature of what the code's doing and go, oh, that's a Singleton, or do you find yourself naming things Singleton just to help?
Just keep in mind, and what Nelson's saying is if anybody comes back in here and looks at this very quickly just by seeing this, they already know without even realizing there's a private constructor in here. But if this was black box scenario where you weren't sure, I mean, the bottom line is down here we're going to name the reference to this instance, whatever we need to make our code readable for us. And you notice he didn't call it Singleton down here. He just called it,
whatever.
It's a doer. Yeah. So back in here, so again, think of this as black box from the outside world, with the case of exception of what's been exposed as our kind of interface to objects to utilize an instance of this guy. So we now have a place to hold an instantiated copy or an instantiation of this class. But the next problem that we have to overcome is the ability for other classes to instantiate this guy over and over and over. And Nelson fixed that by basically closing off the ability for anybody externally to instantiate this guy by
having
simply
a private constructor?
Putting a constructor in that's private.
Yeah.
So the moment he put in private, because see, by saying new, and then what do? You call the name of the class, but if you want to look at it like this, we're calling the constructor.
Yeah.
If the constructor, look at it like a method, is private, you can't call a new constructor from the outside world. It's private.
Right.
So it's just not going to work if you want to use that way of looking at it. So by doing that now, no class externally can ever call new on doer of stuff. Now we have the final problem to solve, and that is, well, how do we generate a copy of it and give it back to people? And that's answered here
public static right
in
there.
the public static.
Right.
Again,
using get
with it
instance
being static, why is it static?
Static so that... Oh, why did my brain just lock up when I wanted to say that?
I don't even want you to look at your notes. Though it's cool that you take a lot of notes, I want you to just think about it logically. Static means there'll only be one version of this method.
Right, and see, that's the thing that keeps tripping me up. It's like, that seems like the whole reason why we have Singleton in the first place, is so that we can do that.
See,
that's
ultimately this is required, and it's a necessary evil. But we can mitigate that by only calling this get instance at certain areas and trying to, for the most of the time, just pass around references to it in the form of interfaces or in the form of a concrete class. So we mitigate it by moving this one method call up as high as we can outside of our application, and the internals of our application doesn't care if it's static or if it is a singleton or not. So it's just a necessary evil.
But back to kind of explaining why static here is we don't want get instanced to be an instanced member. Where that means with each instantiation, each of these objects would then have its own, get instanced method. If that was the case, how would we call get instance? Here's what I mean. Let's jump back down here. How would we actually get instance? There's no way to.
You'd have to create actually.
We have to get it.
instantiate a
We have to
new one.
instantiate it. We can't call new now.
Right.
And we can't get into it. See how it's already underlined it with red.
Yeah.
That this guy doesn't make it, or is not available. But if he's static,
it makes it accessible.
now he's accessible because there can only be one method by this name with this signature. And since it's static, you access it by going through, the class name itself. So then we can say, okay, well, class name itself, dot, and then we can find out everybody that's static on it. We can utilize one of those.
Static is providing that outward accessibility.
That's right. And you've got to have some sort of interface that we can go through in order to get an instance. And how he's doing it is now he's just simply saying, all right, well, we're going to call upon get instance, and get instance returns a reference to doer of stuff, or it's going to return doer of stuff.
Right.
And
if there's something in it, then
so,
we're going to return
what's going to
whatever's in
happen
it.
is we're going to check locally. So now we're inside this class, and we simply check our singleton up here.
Yep.
Okay. I mean, we could even have don't choke, and I already know it's going to be grayed out, Nelson. See how it grays out?
Wow, that was like a death sign.
I know, but I wanted you to see this. It's still this singleton.
Yeah, I see. That's reaching up to the one that's already there.
It's static.
And it has to. Well, it's also private. I mean, we can only reach for it while we're inside this class. So
Notice
okay
how
with
this
that.
is grayed out, and you'll even see if we move this over there. Qualifier is redundant.
Right. And I'm cool with that.
I'm just wanting you to see that this is not instanced on ourselves. It's static. So basically, what we're doing is we're just simply saying, all right, if singleton is null, then let's return back a new doer of stuff.
Right.
That's going to be held in singleton.
Inside Singleton. But yeah, make
Otherwise,
one. Make
return
one if
back,
there wasn't one
that's
there.
Right. Otherwise, return back the reference to that instance of doer of stuff. So the whole heart of the singleton design pattern is it really can be summed up in one. You must have a static member to hold a reference to the instance, and you need to have them private. You must have the constructor being private, so that nobody else can instantiate the class.
Isn't it all relevant that the constructor's not really doing anything here?
Oh, he's doing a lot in a sense as far as functionality is concerned.
I know. I realize that he's got to be there to keep the constructor locked down.
Right.
I understand his purpose for being there. I was wondering if
here,
oh, go ahead.
Here, I just want to point out something real fast that is kind of this class has a constructor.
Even though you don't see
No,
it.
you don't see one.
The C# compiler will generate an empty parameterless constructor that does nothing, and it'll be public.
Right. You only code one in when you want to have something happen, right?
By providing our own constructor, the C# compiler no longer creates that public empty constructor.
Okay.
And so essentially, we're replacing the C# compiler's little magical parameterless constructor with our own parameterless constructor. We're just providing a special modifier on here.
Thank you. That helps.
Yeah, every class, it goes back to what I was saying earlier about new. Every class has got to have a constructor in it, generated by the compiler or generated by us, if we want to actually be able to instantiate it. I mean, that's why it's got.
So that's the next part of the game that we have to have.
So
we've got our
final part is some sort of static property that we can use to
make sure that it's been instantiated.
Method to gain access to an instance version, and that method can generate an instance version of itself and pass it back and store the reference. So that's kind of the three main things.
Which goes down to our variable below, where we were literally calling on doer of stuff dot get instance.
Yeah, exactly.
And then storing that.
So the very, very first time that this is ever hit, then singleton is going to be null. So we're going to create a new reference or a new instance of doer of stuff, store it in singleton, and return that back. So now we're holding that reference right here, and now we can pass it around and do stuff with it. If some other object calls doer of stuff dot get instance, we come back in here. Well, singleton is no longer null. Right. It's pointing to an actual instantiation of doer of stuff. So it just returns that reference back to somebody else who just asked for it as well.
Yeah.
It's important to know here that we can treat this as just a static class. We can do get instance dot increment stuff, and we can do get instance dot print stuff, and that'll work just fine. The problem with this is that this brings back all the problems with static classes. If you're going if you're going to use a singleton pattern in an object-oriented way to avoid referencing static classes, then try to avoid doing this, and instead get the object as soon as possible and use it as a normal object from that point on.
Yeah. So does this make sense, Zach?
It does now.
A little more
the
clear?
little review at the end was very helpful.
Okay, good. So 3 main parts. Store it locally, internally. The seal off the ability for anyone externally to instantiate it with a private constructor.
Right.
And then finally expose some method that is static that people can use externally
to
get an instance, which then will generate and pass back.
Now, get an instance or just get access to the instance that's there?
Well, again,
if there wasn't one, that's why
there
you've
wasn't
got
one,
the non-coalescence.
it's in your
non-coalescence, thank you.
Well, just in his fancy little code.
Yeah, I know.
right
He's
here.
a little fancy, but that's cool.
But
I
the
like
bottom line is internally inside doer of stuff.
Yeah.
If we don't have
Possible nobody had actually
if we've
made
never
an instance of
created
that
our
yet.
instance to
Yeah.
begin with, we're going to create, store it, return it.
Yep.
Otherwise, just return it.
And one more thing. I know someone out there might be thinking of this. What if doer of stuff requires a constructor? What if doer of stuff requires, stuff to be passed in for it to do something?
Mm-hmm.
Like this, how would you handle this? Would you pass in the argument constructors, the arguments for the constructor in get instance? And my response to that would be, if you have an object that has a constructor that takes arguments, it's not a singleton.
Well, okay then.
Well, think about it. It's meant for different conditions in which it's going to be instantiated.
Yeah.
It's variable data coming in. So, yeah, it shouldn't be a singleton. All right, Zach. No, we're here. Zach's thinking.
No, it's just I'm sorry. I was just dwelling on what you were saying. I wasn't expecting everybody to shut up while I was.
No,
thinking.
well, I saw you were thinking, so I was
Yeah.
just waiting to see what you were about to ask.
Well, it's like you would never want to. I mean, okay, just no, I suppose not. I was taking like the math helper class example, and so you'd never want to be able to pass anything into that.
Right. Well, think about it in a really abstract way.
Yeah, because you pass something into the creation of math, not
right,
the methods.
you're right, right, exactly.
But yeah, I do want to
it'd
say
be for
this.
changing functionality, which you don't want to do.
Exactly. It's really useful, at least for me, to think about things in a really, really abstract way. And in essence, a constructor argument is going to change the behavior of your object in some way. If it doesn't change the behavior of your object in some way, that constructor argument is redundant and pointless. So essentially, if you have a constructor argument, you're changing the behavior. If you have two objects that are instantiated with different constructor arguments that have different behaviors, then you don't have, well, a math helper, because math never changes.
Right, I'm with you.
Is everything kind of falling into place?
It is.
Very good. Nelson?
And now we've carried on for like almost 55 minutes.
Yeah, it's been almost an hour. But it's all good stuff. Sorry it wasn't just 5 minutes, Nelson.
That's my fault.
But no, the whole point with these is to make sure you truly understand what you're looking at. I think you've definitely got a better idea now.
Very much so.
Well, cool.
All right, awesome. Well, Nelson, anything else you'd like to add in?
No.
Zach, any other questions?
Not right now, though. I might come up with a couple to start us off on the next video.
And the bottom line is singletons are very, very simple. Very simple.
Yeah, I mean, at the core, it seems like they are.
Yeah, they are.
It was nice to get the review on static. I feel like I've been seeing that for a while
You
now.
have? You have.
And I just don't think we'd ever stop to pull out and talk about it.
Yeah, I don't think so.
And I was pretty vague on the concepts. I think you'd casually explained it to me one day. But it's nice to kind of get it out as a quick review before we really go into this.
Can I just throw something in real fast, Jason? That's
Yeah.
kind of unrelated, but I just want to show it.
Cool.
Best naming ever.
Do you notice how ReSharper even said, fine, he can just have it?
Yeah. I'm tired of dealing with it.
Okay, so static class dot that, and we have
dot flag, right?
stuff that does stuff. Okay, so sometimes you need a static class, and well, to be honest, I can't think of an instance where I've used this in the last year.
But we'll go with it anyway.
Sometimes you need some sort of code to execute in your static class, kind of like a constructor.
Mm-hmm.
So, I don't know, number of files in Cedar. I don't know how that's useful. But maybe you want to somehow calculate this before this method is called. For some reason, this is a terrible design, but you know what okay. So for some reason you want to do this. So to do a static constructor, you do the word static, then static class.
Right, then your name.
The important thing about static constructors, they cannot take method arguments. They cannot be anything but private, or, well, they're not really private or public. They're just there. They don't have any modifiers.
Okay.
And the next thing to note is that they are executed the first time you talk to this method. So then we would do or actually, that might be the first time the assembly's loaded. No, the first time it's referenced.
It's first time it's referenced, yeah.
Yeah.
I haven't used, like I said, I haven't used this in for a year. But if you ever see this, that's what happens, is you can define a static constructor that is called whenever this happens.
Okay.
Or whenever the first time you invoke a method.
Which makes sense, because that's kind of the first time it's loaded up.
Right.
Because something on it's needed, yeah.
Right, right.
I don't know, I just have to make this... Because when I actually name something right, I have to actually make it work. You know what I mean? That's why I use such arbitrary names. Because arbitrary names don't set off my OCD, but this case it does. So that's... Oh, you gotta be kidding me.
Tried to get fancy.
Failed me. Okay, so then we get 13.
Gotcha.
So that's the number of files. Okay.
Awesome.
Terrible design, by the way, but I just want to show this if you've ever encountered this in your code.
Okay.
I'm surprised you haven't asked, well, what would have been the proper design for something as simple as that?
Well, what would have been the proper design? I mean, the only thing that was kind of eluding me, I mean, I realize you're just trying to find a way to squeak in a static constructor, but it's like, so, okay, fine, Nelson, you got to get the number of files on C. Okay, I'll go with that. There you go.
There you go. Whoa. It didn't turn out how I wanted it to. What's going on here? I don't know why I have size in there. That's the jQuery count equivalent. Anyway, that's what I would do.
I can, yeah, okay, so you're setting up an interface that dictates that we have to have a method that's going to return an int that takes in a path.
Yep.
All right, and then we create a class called fileCounter, which is, I want to say utilizing that interface. What's the word for it? Implementing that interface. Thank you. So, and that's going to have our count4, which it's, of course, it has to, and that's returning an integer based on the command directory.get files for whatever path we've fed into it, and then it'll just fire off the count, which I guess is link giving you the count?
Yes.
Okay.
It's a link method.
All right.
So I can play Zach here and continue with that with, well, that's nice, Nelson, but the functionality for getting the file count, I mean, you called it file counter, and that's what it's doing. It's getting that. It's kind of like adding or, dividing, and that functionality is never going to change. So you're telling me now every time I want to get the count of something, everybody has to instantiate a file counter?
This is such a contrived example. This, I would never abstract this into anything. I wouldn't even put this in a static method. I would just do that.
Right. And that makes the most sense. I mean, that's a really long way to go about it. But.
Honest to God, when I thought he was going to redo it, when he put interface, I was kind of surprised because I figured he would delete everything and take pretty much the line that's highlighted and just put it down in main.
Yeah, exactly.
I should have done that. But you said proper design, and that fired off my domain modeling. Synopsis.
Proper means lots more code than you need to get the job done.
It's still fun for people to watch and then hear us have fun anyway.
Oh, yeah. Well, we do a lot of fighting, and it's important that we fight a lot.
We just discussed things, Zach. All right, well, we're at an hour now, so we'll wrap things up for tonight. And then tomorrow night, if Nelson's up for it, we'll take a look at factory patterns.
Sounds good to me.
Which are really cool and very useful, without a doubt. Well, Nelson, thank you very much for tonight, sir. And Zach, thank you as well.
Thank you.
And thank you out there to all of our member sponsors for tuning in and supporting 3D Buzz. And with that, that is going to wrap up Episode 8 of Nelson's Corner. Good night, everyone.